Hey class, today we're going to be talking about Objective 2 of 6.5. For this lecture, I thought I'd go straight into an example, so that way I could just explain how you solve one of these problems instead of going into the theory and then trying to do example problems. So again, you should be taking notes of this lecture and then uploading them to Schoology. So let's start off with the point -12, 9. So here, we're going back to the xy coordinates. So remember that for this, we're going to have the xy plane. And what it's saying is we're going to be at -12 and 9, somewhere around here. So this is going to be a point on the terminal side of an angle theta. So since this point, 12, -12, 9, is on the terminal side of an angle, that means that the angle must be this if it's in standard position and if it's the least non-negative coterminal angle of this angle. So this point, -12, 9, is just in the standard x, y notation. Now, we want to use this point to find the exact values of the 6 trig functions of theta. So how do we do that? Well, if we look at some general angle with points x and y, and let's make them both positive for simplicity's sake. So say the terminal side is here, and we want this point. So this distance right here, going down, is going to be its y coordinate. And this side is going to be its x coordinate. So this point is going to be xy. Now, this terminal side is forming some angle theta. And that point is a distance r from the origin, 0, 0. So we define r as the square root of x squared plus y squared. This is just the Pythagorean theorem, right? So we have a right angle that's right here. We have our legs of length x and y, and our hypotenuse is just going to be equal to the sum of their squares. Okay, now we can start phrasing our trig functions in terms of this general theta that we've derived. So if we're looking at this blue theta right here, we can say that sine theta is going to be equal to opposite over hypotenuse. In this case, it's y over r. Similarly, we can look at cosine of theta, which is adjacent over hypotenuse, which is going to be x over r. And then we look at tangent of theta, and tangent of theta is opposite over adjacent, which is y over x. Using our inverse functions, we can see that cosecant theta is equal to r over y. Secant theta is equal to r over x. And cotangent theta is equal to x over y. Now, for a general angle whose terminal side has a point, xy, these are going to be the trig functions of that angle theta, no matter what. So looking back at our example, right, we have a point -12, 9, and we want to find the exact values of the 6 trig functions of theta. Okay. I moved the screen down a little bit so that way we could have some more room. What we're going to do first is we want to find r. So like I said, r is going to be the hypotenuse of this triangle, and it's just the square root of x squared plus y squared. So we have r is equal to the square root of -12 squared plus 9 squared. When you do this, you get r is equal to the square root of 225, which means that r is equal to 15. So this gives us our value of r that we can use for our trig functions. We already had given to us that x was equal to -12 and y was equal to 9. So now that we have all of these values, we can reference our new definitions over here to the right, and we can find all of the values for this theta. And what we will find is that sine theta is equal to y over r, which is equal to 9 over 15, which can be simplified to 3 over 5. Cosine theta is equal to x over r, which is -12 over 15. And this is going to be simplified to -4 over 5. Lastly, we have tangent, and that's equal to x over y, or sorry, y over x. So we have 9 over -12. And that's going to simplify to -3/4. And if I move the screen down just a bit, we can then write secant theta as the inverse of sine theta. So that's 5 over 3. Or I'm sorry, I think I said secant, but I meant to say cosecant. Secant theta is the inverse of cosine, so that's -5 over 4. And cotangent theta is going to be the inverse of tangent, which is equal to -4 over 3. So this is how you find the six trig functions given a general point on the terminal side of an angle.